I'm going to talk about something related to containers, though, relating to how we get outside the boundary of the container itself. So 2014 was a good year for something. Must have been something in the air because that's when Singularity, as Greg was talking about, started its run. It's all the same time we started working on a thing called PMIx, which usually gets called PMIx. So we were standing around and we were looking at some of the issues that we were facing in the high performance world. And we were looking at things like launch time scaling, which was going up, especially for Exascale machines. We were looking at tens of minutes to start the darn thing. Then we were also looking at people wanting to create these hybrid applications where we had MPI and OpenMP in particular together. But there were other combinations. We have people that want to do like Spark with MPI, for example. So we were trying to figure out how we accommodate those. We had the tool vendors talking to us, like with TotalView and DDT and stuff, where we've got these great debuggers, but you can't use them in anything but MPI. And why is that? Well, because their interface to the programming library was defined by MPI, and it's in a very MPI-friendly format, not necessarily for anything else. So, okay, well then how do we generalize that? We started looking at all these proliferation of programming models and runtimes. It seemed like everybody who came up with a new idea for a programming workflow had to write their own runtime. And that seemed a little silly. And so, and then of course, we started looking at the rise of these container technologies that were out there. And we started saying, well, isn't there something we can do that maybe crosses all these different things? So we quit writing special things for each one of them. So we said, let's start someplace. It was just too big a problem to try and do at one time. So we said, all right, let's at least start with resolving the launch scaling time. So if you look at the launch of an MPI application, for example, you see that you launch all the processes, and the first thing each process does is it publishes a bunch of information about itself. Where am I? What endpoint am I listening on? How much memory is on my node, et cetera. And then they do this great big global exchange across all the processes where everybody exchanges all this information and gets a unique copy of it to themselves. And then they all go ahead and pull out of that whatever it is they actually needed, which is usually a fraction of what they just exchanged. Well, in an exascale size machine, that collective is enormous. I mean, it's on the order of uncompressed, about 250 megabytes of data is flying around between all these different processes, which is kind of a lot. And so we said, well, let's take a look at what's in that data. And we found that better than 80% of it was already stuff that was known to the local resource manager, Damon, that started the process to begin with. It was all kinds of stuff about the job and things that was already well known. It's just that the resource manager never bothered to tell the process what it was. And then we looked and said, okay, well, that chops things way down. What else can we do? Well, instead of everybody doing dynamic endpoints, we could pre-assign the endpoints, sort of like with TCP, with a static socket, for example. That got rid of a whole bunch of more of the stuff. And so by the time we were done with all the things we could do, if just the resource manager communicated it down, and we did a little bit of integration into the launch procedure between the different subsystems, you can actually completely eliminate the data exchange altogether. And so basically you start the process. As soon as the process executes, it knows how to communicate to anybody, and you're ready to go. So the launch time went down from about 20 minutes on Exascale computer to less than 10 seconds. So we were pretty happy with that. It did involve a bunch of orchestration. So I'm not going to walk you through all of this launch procedure. It's fairly complex. But the main points to it really are that you are integrating. There are things the scheduler needs to talk to the file system about. There are things it needs to ask the fabric about. And then if it can do that, and it can pre-cache things and tell things the file system where it's going to be putting nodes and stuff, that's how this whole thing gets down to only a few seconds to launch a gigantic job. So in doing that, then you create these three entities. So there's a PMIx Standard that's out there. We published version 3.1 of it a few weeks ago. That basically just tells you, okay, here are all the APIs you need for the process to talk to the PMIx server, and for the PMIx server and the scheduler to talk to all these different subsystems. So that I mean, if you talk to the resource manager guys, they bought into this because they said, okay, you're going to write all the interface code to the different file systems. You're going to write all the interface code to the different fabrics. I'll call the API to say, hey, Fabric, tell me what all the endpoints are. But I don't want to write the code that goes and has to talk to a Mellanox fabric versus an Intel fabric versus a TCP fabric. You're going to do that. And so we got the different fabric vendors together, and they each did that. So the resource manager guys don't have to. Those APIs are all defined in that standard. Then there's a reference implementation that we wrote as a community, and that's got all the implementation of the standard in there. Nobody has to use it, but so far everybody is using it just because it's a lot of code and nobody else wants to write it. But it's just basically an implementation of the standard. And then we created this reference RTE, and we did that because people wanted to develop their codes against PMIx, but it's taking time for PMIx to roll out in all the resource managers. You know, Slurm started 4 years ago now, putting it out there. I think it was 3 years. PBS is coming out this year. IBM's had it out in their Coral machines for about a year or two now. So, I mean, it's been rolling out, but it takes time. So the reference RTE gives you a way that you can launch what looks like a PMIx-enabled resource manager on your machine and run a PMIx-enabled code inside it. And it works just like it would normally. So this is where it's currently used in this form, right? So all the MPI libraries now have adopted it. It's in all the OpenSHMEM libraries that I know about, at least. You can see the list of resource managers that are in there. Los Alamos has a project. They're going to actually enhance the Slurm implementation so it covers more of the standard. And then there are all these use cases that have been out there that have been starting to show up. We've got people integrating it into Spark and TensorFlow. The debugger guys are actively working now to get their tools built into it, et cetera. So there's been a lot of adoption of this. And you're seeing it in the containers as well, as Greg was mentioning. The MPI containers, OpenMPI in particular, we integrated with Singularity back at the beginning, Singularity 1.0, and that uses a PMIx interface. So, okay, so once you have that in place, if you go back, we were looking at those like 5 or 6 problems we were up against. Said, okay, well then, what else can we do with it? Well, the obvious thing is, all right, you've got the resource managers agreeing that they're going to put it in their system. You've got the fabric guys on board. You've got the file system guys on board. So what do you do with all that? What can you do? And so we started building on it. And one of the first things we added was an asynchronous event notification system, so that I can say I would like to know about when processes die in my job, and get an asynchronous notification to my program in a callback function telling me that process 5 died, and maybe some information about why it died, like the node overheated and I had to shut it down. And then I can respond to it because I can generate my own asynchronous events, and they can go to the resource manager, they can go to my other processes, they can go anywhere I want. So I create this event notification infrastructure. Well, the first thing that the people that jumped on that was the guys doing the hybrid applications, because they said one of the biggest problems we're up against is that if I'm running OpenMP, I don't know that this guy's running MPI inside the same process and vice versa. Yet they compete for the resources. So the OpenMP guy's trying to, I want to lock everything over in here into these cores. The MPI guy's saying, no, I want to bind it over there. Everything gets confused. So one of the first things we did was we said, okay, we created an internal event in this event infrastructure. So when these two models now come up, MPI or OpenMP, they declare that they're there in a PMIx event. And that event is cached. So when the other model opens up and initializes, it gets an event telling it, hey, the other guy is here. And he also generates an event that goes back to the other model and says, hey, this guy just initialized. He's here too. So Jeff Waugh, I don't know if Jeff Waugh made it to the thing. He had a paper he was going to talk about here where he actually has implemented this in OpenMP and in OpenMPI, where he's got the two models actually communicating with each other and handshaking through this event notification system to coordinate their assignment of resources. And he actually has parallel sections, for example, in OpenMP that cause the MPI section to back off, for example, during that period of time, and vice versa. So it's really kind of interesting what people are playing with. Then for the tool guys, they said, well, okay, what we can do is, since you're now talking to the resource manager, what we want to do is we want to stop having to launch our own daemons, because it takes a lot of effort to write all this launch code, and it's even more harder to make it scale. So what we really would like to do is we would like to tell the resource manager, wherever this job is, I want you to launch a daemon on every one of those locations. And I want you to tell the daemon what job it is I'm trying to debug, and I'd like that daemon to be able to query and get what the proc table is globally as well as locally, et cetera. And so we created the infrastructure for doing that. So there's actually when you can actually ask the resource manager to co-spawn a set of daemons, co-located with whatever processes you want, whatever job you want. You can query the resource manager for the proc tables, both globally and locally to where you are. You can query about what the network traffic pattern looks like, so you can actually query the fabric manager and find out what links are loaded, which ones are not. The guys at Oak Ridge are playing with it. They actually are able now they basically created an event inside the MPI process so that you can query the actual MPI process and ask it to look at its internal counters for you and return the information. So the debugger guys now have a whole bunch of ways that they can interact with these things at scale. So then we said, okay, well, that covered those two blocks, but now what else is left? Well, what's left, of course, is dealing with these new programming models and containers and stuff. And so we looked first at the programming models problem, and we said, okay, well, if you look at those, the reason there's a mismatch with HPC is because they tend to be dynamic in the way that they start their processes, and they tend to be dynamic in the way they want to define or aggregate processes into groups, and that then do something together. So we added the ability to flexibly change the allocation. So we added APIs that allow you to request changes in the allocation. You can, at the request of the cloud guys, you can even do things like loan nodes back. So where you can say, hey, look, resource manager, I give you back these 10 nodes because I'm not going to use them, but I have a right to preempt them back at a later time. And so some of the cloud guys are playing with that. Then you can also register your job and say, I'm willing to be preempted. And then when it's time to be preempted, there's a handshake that's been defined that says, I'm going to preempt you. And then you can ask for time to do, for example, a checkpoint. And then when you're done with the checkpoint, you can say, okay, I'm ready to be preempted, and then be preempted. So there's a way to make this stuff a little bit more friendly. The next thing was that the Spark guys and the MPI guys as well, it turned out almost at the same time, came back and said, well, we want ability to have these dynamic group constructions and destructions. So we created the ability to do that earlier this year, in fact, where you can actually say, I want to construct a group asynchronously. So here are some processes I'd like to have in a group. It just means that they know about each other, is all it means as far as PMIx is concerned. But they do know how to talk to each other. So you get all the connection information as well as the job information exchanged between them as part of the formation. But you can also start this up asynchronously. Say, I want to invite these guys to this job. Whenever they get around to it, let me know. And then you can go ahead and we will notify you when each one of them joins until they've all joined. And then you can do whatever you want. And then we notify you when they leave, which you can either do synchronously or asynchronously. So it's sort of a flexible way of just saying, I want to make this group of processes know about each other. And then finally, we started working on file system integration, basically trying to work with people like Luster and be able to pre-cache their files out into NVRAM located throughout the cluster. So when you get done with all this, this is kind of what it looks like. You've got an application that might be a hybrid application. It's got a PMIx client library inside that is initialized. Then you've got the system management stack out there, and one member of it, and it's usually the resource manager, is running a PMIx server library inside of it, and it's coordinating all the requests coming out of the client into the system management stack. And then, as I said earlier, the resource manager guys didn't want to write the code to talk to all this, and so there's a piece of PMIx that actually does that for them. So they can say, hey, I have a request for the fabric, and we take care of the abstraction layer of talking to the fabric. Well, after we got done getting to that stage, we took a closer look at that and said, gee, that looks like a container. And so if you then say, well, that is a container, then you run into several issues. And they're not simple ones, frankly. And they're all based around one thing, and that is that the container has to talk to something outside of itself in order to work, right? It has to talk to a resource manager that's telling it how to communicate with other parties. It's got to talk to a resource manager to ask it for resources. There are things it needs to do across that container boundary, and that's not standardized. So one of the first problems that you started running into when we started doing playing with containers was it, I think Greg was talking about it, others have talked about it here too, it is they aren't portable. You can't build a container on a PBS system and take that container and run it on a Slurm system. It won't work. Okay. Yeah. I'm saying it's not efficient. Okay, not that it's impossible. It's not efficient. What we'd like to do instead is have a mechanism that you don't have to do that, because you have to do that for every single system where you might want to run it. And you can't do it necessarily for all of them because some of them are just too foreign, right? And so you wind up, you know, like trying to run something that was built under Kubernetes on a cray. HPC. Right. Right. Yes, exactly. Exactly. And there are let's say there are vendors who are happy to help do that, right? Lock in. And I'm kind of on the other end of the thing of saying I don't want anybody to lock you into anything. That's the best way to put it. But yeah, so these are the three things we ran into pretty much right away. So we addressed the first one because it was the easiest, and that was version tracking. You know, if I'm going to have an interface that goes across the boundary, there's two ways to attack the fact that that both parties on the boundary, on either side of that boundary, may be changing at different rates. All right, I may update my system software faster than I'm going to really rebuild my container. So one way you can solve it, of course, is to standardize your protocol and never ever let it change. We decided that we didn't really want to tackle that one. So instead what we did was we created the ability for the PMIx client and server basically to handshake their protocol levels and then guarantee that they always are able to cross-communicate. Basically, they find out what the other guy is talking, they pick the highest common value between the two versions protocols, and then that's the one they lock in on and use. And so we've been able, it took us a year to get it going, but basically you can see the chart over there, but anything from version 2.1.1 and above is interchangeable. So with that in hand, we then said, okay, well, that leaves these two guys, and so what are we going to do about those? And that's really the question that we started talking with Greg and his guys over there at Sylabs about, you know, late last year and early this year. And we kind of came up with this idea that we called epics, because it would be really epic if we were able to pull it off. We've kind of got a skeleton in mind. We have not actually written code yet, so this is more a a discussion of, hey, here's where we think we want to go. But basically the idea is that, well, if we say that the primary interface is going to be through this PMIx arrangement, then the next question is that, what we could do is we could create a daemon inside the container that basically acts as a relay and as a leveler, if you will. So when it starts up, it senses what the resource manager, what the external environment looks like, okay? What does it support? And then anything that the client requests or that the external guy pumps in that we support, that we know that the other guy supports, whether it's the client supports or the server supports, we just relay through. We're just a pass-through. If there's something we know that they don't support, then we look inside ourselves and say, is there something we do? For example, PMIx allows you to log messages. So you can log it into the job control record if you want, or you can log it into syslog or anything like that, like, I got this far kind of thing. So if you were asked us to log something, even if the resource manager didn't have that ability, didn't support that particular function, well, EPIX might be able to do it for you and just does it. Otherwise, it would return not supported. So, okay, so we were able to handle supported stuff. We just pass through, we discover what's out there, and then we execute whatever is left that we can. So that means then what do we do about this situation, which is where the system environment, the system management stack is able to do what you asked for, but the resource manager did not integrate that level of support. In PMIx, the way you get the resource manager community to agree to support you is that you say you never require them to do anything, right? So you don't have to support any given function. You can always say not supported. So, okay, what do we do in that scenario? And what we decided we'd do is we'd take advantage of all that work they made us do, and we would actually go ahead and say, all right, so what we'll do then, in that case, is we will be the interface to all the rest of them. So in other words, instead of going to the resource manager and saying, you talk to the fabric, if the resource manager doesn't support that particular PMIx capability, then EPIX will go talk to the fabric for you. And that'll fill in the gaps. And the question then becomes, who writes all those drivers? And the answer is, well, the PMIx community does, and thankfully we already did. So that's easier. So then the other way around is, okay, what if I want to run an HPC on a container manager like this? How do I handle that problem? And we did develop a thing that we're talking to the Kubernetes guys about through Greg's team, and we need to go a little deeper into. But the basic idea is we're going to try and take advantage of the allocation requests and the event notification system to allow an HPC system to say, I need you to stabilize this allocation for some period of time. And if there's any reason why it needs to change, there's a handshake so I can at least try and resolve the problem. And likewise, we're talking with the guys at places like Slurm about, okay, I want to run a service that looks just like a Kubernetes service, but I want to run it under Slurm. We have all these APIs in place. Can we use you guys that way? And the answer is yeah. If you go ahead and you register that you're a service, so I know that you're going to be doing this, but then you can also go through various things like registering for an auto start and multiple replicas and things like that. And then the capability to support that will be built in. So why do this? Because of that thing, that we want to be able to take a container and move it across these boundaries and not have to do a ton of individualized work. So in summary, the whole idea behind this, of this extension that we're talking about with EPIX, is to just get away from writing an entire runtime. I mean, if you look at these different runtimes, over 90% of them is all the same, right? You got to launch, you got to wire up I/O, you got to do all this stuff. So you got tools connections and every this other stuff. There's no reason to have to rewrite an entire runtime just because you want to be, want flexible scheduling or something. There ought to be a way to interact with the resource manager and do that. So, and obviously we will need help. Anybody who thinks this might sound interesting to them, please come tell me. We would like to get some people to help with it. So, so if you're interested in any of this, and I'm sorry I have to run through it like this, but come join us. It's a pretty active community, and we would love to share beer and talk about it. So, if there are any questions, stuff, this is just some links to some general information that's out there, several different places.
Any other questions for Ralph at this time? Let me give you the mic.
Do you think this could help at all with some of the MPI ABI compatibility issues that we currently see? Could I somehow avoid having to be dependent on, say, a particular MPI version and just rely on this EPIX, or am I missing something?
Yeah, I don't think so. I don't think it'll work. The ABI issue is more like when you call MPI all gather. I mean, there's where the ABI occurs, and PMIx isn't in there. It's more in the when
Lower.
when you want to send a
When
message.
I build OpenMPI 3, I get PMIx, right?
Yeah. You know, it's down more at the point at where you're saying, okay, well, in order to do that MPI all gather, I have to communicate from here to here. What's this? How do I do that? What's this guy's rendezvous point? And that's when PMIx gets involved to say, oh, I know that information. I can give that to you. You don't have to go and ask for it. So it's a little below that.
Okay.
Maybe have time for two other questions. I used to work for Alinea before they were acquired by ARM, and there was a requirement that they had to be able to debug at the full scale of Blue Waters, for example. How scalable is PMIx?
Well,
In like a debugger or whatever context?
Okay, so what we do with the debugger is we take the debugger and we piggyback it on the resource manager, right? So the knock on the debugger has been that you got the launch, which is usually done by SSH because they don't have any interface. That way, they don't want to write interfaces to all the resource managers. Well, now you task the resource manager to launch for you. So your scaling on the launch is now as fast as the resource manager can launch it, which has to be scalable on Blue Waters and stuff. And then you piggyback the I/O across the resource manager as well. So PMIx has APIs that will forward your standard input to the process through the resource manager's I/O forwarding system and stuff. So what it does basically is it allows you to get rid of all that code you had to write to try and be scalable, and instead just rely on the scalability of the resource manager and make them do the work.